All right, it says enclosing a rectangular field. It says David has 400 yards of fencing and wishes to enclose a rectangular area. A, express the area A of the rectangle as a function of the width W of the rectangle. B, for what value of W is the area largest? And C, what is the maximum area? Okay, so first we need to draw, what it's talking about. That does help when you draw a picture. So let's go ahead and do that. All right, so we have this rectangular area, okay? And um, so we're going to need two equations here. All right, one is for the area and the other one's going to be for the perimeter. Okay, and we need two of them in order to um, get our answers here. So it says first is express the area A of the rectangle as a function of the width W of the rectangle. So if we were to label this, right? So this would be our length width, okay? And so if the bottom is L, the top will also be L, right? Because these are parallel. And if this is W on this side, the other side will be W as well. Okay. So if we're just talking about the perimeter, right? The perimeter will be just around the shape, right? So you just add up all the shapes. So it'll be L plus W, or you can just write it as the perimeter is equal to 2L plus 2W, right? That's what perimeter means. We're just adding the outside lengths. All right, so that's one equation. The other equation we need is when it's talking about the area. So to find the area of rectangle, it's just going to be base times height or length times width. So this is for A, all right, the area is equal to length times the width. Okay, all right. So in this case, what it wants us is to express the area. So we need to express this area in terms of W. Okay. So what that means is that right now we have two variables. So we need to rewrite it in a way that we only have in terms of one variable. And preferably they say W. So that means we need to figure out how to replace L. Okay? And this is where the other equation kicks in or comes into play. All right? So we know the perimeter. The perimeter here is 400 yards. That's how much he's going to use to enclose the rectangular area. So we can replace P with 400. Okay. And then we have 2L plus 2W. All right. And then what we can do is we need to solve for L because again, we need to get rid of L here or replace L with W. So in this case, we need to solve here for L. Okay. So we're going to subtract 2W on both sides. So we get 400 minus 2W equals 2L. And then we're going to divide both sides by 2. Okay, so 400 divided by 2 is 200. And then 2W divided by 2 is just going to be W. Okay, so that means L is equal to 200 minus W. All right, so what does that mean? That means we need to replace our L here by this equation. Okay, so we're going to take this and we're going to plug it in here. All right, so that's what we're going to do. All right, so now this is going to be 200 minus W times W. Okay, all right, and then we're just going to distribute that W to each term. So that's going to be 200 W minus W squared. Okay. And then I like to rearrange this so that the leading power is always in the front. So I have of W equals minus W squared plus 200W. Okay. And so this is what they want. They said express the area A of the rectangle as a function of the width W. That's what they have. So that's what we have here. All right, we express the area A as a function of the width W. All right, so this will be our answer for part A. Okay. All right, any questions on how we derive this one? Okay. All right, so let's look at the second one. Okay, it says W, for what value of W is the area the largest? For what value of W is the area the largest? So now think about what we've been doing during this week. We talked about maximizing or minimizing um, volumes or areas or things like that. And we introduced another formula, and that formula was x equals negative b over 2a. All right. So when we're talking about maximizing or minimizing something, we need this formula. Okay. So x equals negative b over 2a. All right. So where's this information going to come from? Well, it's going to come from the equation that we just derived. Okay. So that's why I like putting this in order, because now I know that this one here, right, this negative 1, that's going to be my A. And then 200 is going to be my B. Okay. And then I just plug it in. All right. So I have negative 200 divided by 2 times negative 1. So when I put that in the calculator, I get negative 200 divided by negative 2, which is going to be a positive 100. Okay. So that's my answer for X, or in this case, it can be any variable. And so we can put X or we can put W. All right. So that's what our W is 100. Okay. So for what value of W is the area largest? Well, it would be this, right? 100. Okay. So again, it doesn't matter what variable you use here. It could be X, W, T, doesn't matter. All right. But the general form, it is X equals negative B over 2A. All right. So then let's look at the last part here. Okay. And it says, for what is the maximum area? So remember, to find the maximum area, all right, is we just plug it back into the original function. So we derive this function here. So all we're doing now is going to plug in 100 every time we see a W. So this is going to be A of 100 is equal to negative 100 squared plus 200 times 100. Okay? So go ahead and put that in the calculator and tell me what you get there. All right, so when we enter this in the calculator, the answer to this is going to be 10,000, right? And this would be since we're talking about yards, so this would be square yards. Okay, so that's our answer for part C. Okay, it says enclosing the most area with the fence, a farmer with 4,000 meters of fencing wants to enclose a rectangular plot that borders on the river. If the farmer does not fence the side along the river, what is the largest area that can be enclosed? All right. So in the previous problem that we had, we were using all 4 sides, right? So this one we were all using 4 sides. But in this case, it's only using 3 sides, okay? Because it says the farmer does not fence the side along the river. right? So we're not using this here. So if I were to label this, right? If we're going to follow off what we had last one, okay, my L will be the bottom here, okay? And then this will be my W, right? So if this is W, then this is also W, right? So in this case, we'll have the perimeter is equal to um, 2W plus L, okay? Now, do we know the perimeter? Yes. It's telling us we can use 4,000 meters of fencing. So we're going to replace P with 4,000. Okay, so that's going to give us 4,000 equals 2W plus L, right? So again, this is one of the equations that we need. The other one that we need is the area, right? Because it's talking about what is the largest area that can be enclosed. So we'll need to use that one. So A is equal to um, L times W. Now we follow what we did last time. We want to put this in terms of W. Okay. So um, so I'm going to have A of W. Okay. And I'm going to replace L. Okay. Because again, we want all the variables to be in terms of one variable, in this case, W. So here we're going to solve for L here. Okay. So let me do that. So we're just going to subtract 2W on each side. Okay. So in this case, we get L is equal to 4,000 minus 2W. Okay. So what am I going to do? I'm going to take this information that we just got, and then I'm going to replace that with an L. Okay. All right. So then we have 4,000 minus 2W times that by W. Okay. All right. Does anybody have any questions how we got to this point? This is probably the hardest part. Okay. All right. Okay. So now we're going to distribute that W. So, right. So we're going to multiply that. So we're going to get 4,000 W minus 2W squared. Okay. Again, this is still AW. And as I did before, I'm going to rearrange this so that the leading power, right, the leading term will be the highest power. So this will be negative 2W squared. Again, do you have to do that? No, but it does help when we use when we use the other formula to maximize the area. So negative 2W plus 4,000W. Okay. All right. So again, our goal is to find out the largest area. So in order to do that, we need to use that formula, which is x equals negative b over 2a. Okay. All right. So we're going to label this. So this is going to be our a, and this is going to be our b. And then we just plug it in. All right. So that'll be negative 4,000 divided by 2 times negative 2. Okay. Okay, so um, when you put this in the calculator, well, negative 4,000 divided by 2 times negative 2, which is negative 4. So negative 4,000 by negative 4 will give us 1,000. Okay. All right. But again, we want to find the largest area. This is what X is, or in this case, W, right? X is the same thing as W. Okay, because we're just using a different variable here. So we're just going to plug in our 1,000 here to W. Okay. All right. So let's go ahead and do that. So we get A of 1,000 equals negative 2 times 1,000 squared plus 4,000 times 1,000. Okay. All right. So some of you were close in submitting your answers, but the answer here should be 2 million. Okay, square meters. Okay, maybe you got the equation correct. Maybe there was maybe a typing error in the calculator, so just make sure you just double check that. Okay, all right. But anyway, this is the largest area that can be enclosed um, in this problem.